Alright, welcome to this next video from the Academic Success Center for Gen Chem 1 Help. We're looking at empirical and molecular formulas in this video. So, first thing we need to do is define them. And by the way, this document is going to be available for download in the video description on YouTube, so you shouldn't have to go too far. And there will also be a link to some extra review problems with the answers attached to them in the description as well. So what is an empirical formula? Well, an empirical formula is the most reduced form of a compound. It differs from the molecular formula because the molecular formula tells you the actual number of atoms in the compound. But the molecular formula must be a multiple of the empirical formula. And when we go through a couple of these practice problems, you'll see what I mean by that. So here's the first example problem. .6 grams of magnesium ribbon are allowed to burn until completely reacted with oxygen. The mass of the product is found to be 9.3 grams. What is its empirical formula? So here's your process right here. First, account for all the masses. Second, convert all the masses of the reactants to moles. Set up your current formula based off the moles, and then reduce by dividing by the smallest number of moles to find your answer. So we're going to do it step by step. So first, I have my 9.3 grams of product. And that has to equal the 5.6 grams of magnesium, and magnesium is Mg, plus whatever mass of oxygen that I used. So I have to solve for x, and I get 3.7 grams to be my mass of oxygen. Alright, so first step, not too bad. Now, in order to convert to moles, I need my periodic table here. Here's Mg, its mass is 24.31. And here's oxygen, its mass is 16. So I have 5.6 grams of Mg times 1 mole over 24.31 grams. And that equals 0.23 moles of Mg. Alright, I'm going to do the same thing for oxygen now. 3.7 grams of O times 1 mole over 16 grams. Gives me a look at that, 0.23. So what's my formula look like now? That third step. I have Mg 0.23, O 0.23. So my moles become my subscript. Let's make a note of that up here. Moles become subscripts. Now, I divide by the smallest number. Well, in this case, it's the same number. And I get MgO. So hopefully, not too bad. And this process is going to hold no matter what the situation is. So here's the next example. So given the masses, find the molecular formula. So 3.90 gram sample of carbon was exposed to hydrogen until the entire sample completely reacted. The final product, ethane, was a gaseous compound that was collected and massed at 4.87 grams. If ethane has a molar mass of 30.06, what is its molecular formula based off this experiment? So same process. I need to account for all my masses. Well, I've got the mass of carbon, I've got the final mass, I still need the mass of hydrogen. So, same idea as before. 4.87 grams of product has to be 3.90 grams of carbon plus X grams of hydrogen. So 4.87 minus 3.90 equals X. And just to save room, I'm going to do it all in the same line. We get 0.97 grams. Alright, so there's my mass of hydrogen. Now, second step is go to moles. 3.90 grams of carbon times 1 mole over 12 equals 0.325 moles of carbon. So over a bit. 0.97 grams of hydrogen times 1 mole over 1.01 grams equals 0.96. And that's moles of H. Now this time my numbers are going to be different. Carbon is 0.325 and H is 0.96. So I divide by 0.325 and I get C. H comes out to be 2.95, and that's close enough to 3 that I can just round it. Alright, but this, remember, is looking for the molecular formula. So here are my extra steps. First, find the molar mass of the empirical formula. Well, I have 1 carbon and 3 hydrogens. So that's 12. This is 3.03. And they add up to 15.03 grams per mole. Divide the molar mass of the molecular formula by the molar mass of the empirical formula. So according to up here, that thing's molar mass was 30.06. grams per mole over 15.03 grams per mole, and that gets me 2. So big deal, what do I do with that 2? Well, I take my CH3 and multiply all the subscripts by 2, which gives me C2H6, and that's my answer. Alright? Everything you have to remember in chemistry is just a process. Step by step, don't skip anything. Alright, one last type of problem I want to go over in this video. And that's what you do. Oops. When you're given percent composition, and that point you find the empirical formula. You can only find the molecular formula if you're given the molar mass of the molecular formula. So in this case, we're just looking for the empirical formula. So a compound is found to have 58.81% barium, 13.73% sulfur, and the rest is oxygen. Determine its empirical formula. So here's what you do to change things. When given a percent question, always assume 100 grams of the compound. Then the percents are the masses of each element, and the process is the same. So, and notice I didn't put numbers here, so we're going to have to do this a little bit more freeform. So we have 58.81 grams of Ba, 13.73 grams of sulfur, and the rest is oxygen. So I know it's 100 minus 58.81 0.81 minus 13.73, and I get 27.46. So that's my grams of oxygen. Alright, so what's the next part of this process? Well, I have to convert everything to moles. So 58.81 grams of Ba times 1 mole over, and barium's mass is 137.3, and that gets me 0.4283. Alright, so I'm going to have a lot of numbers here, so I'm going to underline this because this is an important number. For sulfur, 13.73 grams of S times 1 mole over, and sulfur is 32.05 grams, and that gets me 0.4284 moles of sulfur. So again, an important value, I'm going to underline it. And finally, oxygen, 27.46 grams of O times 1 mole over, remember oxygen is 16. And for this one, we get 1.716 moles of O. So right now my formula is Ba 0.4283, S 0.4284, and O 1.716. Well, my smallest number there is 0.4283. And I get Ba, that's going to be about 1. And oxygen, I get 4.007, so we're just going to call this one BaSO4. And that's all you do. Now, real quick, before this video ends, I want to go over one other possibility. Let's say you ended up with something like this, Ca 1.5 N1. Well, you can't round that one. Alright, so there's some decimals you can't round. 0.5, 0.33, 0.25. Instead, multiply everything by 2 for this one. For this one you multiply by 3, this one you multiply by 4. So in this case, I'm going to multiply each of those by 2. And 1.5 times 2 is 3, and 1 times 2 is 2. So that would be my final answer for this one. Alright, so that's empirical and molecular formulas. I'll see you in the next video.